Introducing uniform distribution. Uniform distribution, do you see this? What does that mean? This one, I wrote that x follows. So this is a random variable x. That means follows. Uniform distribution. And then x is from this minimum to this maximum. A is a minimum, B is a maximum. When you work on a uniform distribution problem, the problem provides a minimum and a maximum. So what you need to pick up is you need to read the problem statements, and then you need to find out that this is for a uniform distribution. They will just say it. They will just use the word uniform distribution, and then they will provide a minimum A and a maximum B. Okay, so for the entire sentence, so we will say let x be a continuous random variable. Following uniform distribution. So following uniform distribution. Okay, let's highlight that. So let me highlight this a uniform distribution, and then with a lower limit A and upper limit B. With, okay, let's use a different color for A. So with a lower limit, x equals to A, and an upper limit, and upper limit, x equals to B. Okay, lower limit is x equals to A, upper limit is x equals to B, and then in short, because you know that math people, stats people, they like to use symbol instead of writing a full sentence. They say x follows uniform. Sometimes they just use a capital letter U, uniform distribution with lower limit A and then upper limit B. So lower limit is A, upper limit is B. I will just follow the color. And then there is a function for uniform distribution. The function is we write the following. So we write this. We write that f of x. This is not f times x. This is a function. So that what that means is f of x. Okay, f of x. X is a random variable. F is the name of the function. That is equals to 1 over the maximum minus the minimum. So let me follow the color, and then maximum is in purple, and then the minimum is in green. 1 over the maximum minus minimum. Very easy. You have 1 over maximum minus minimum, and then this is the function when x is between A and B. When x is between A and B. And then what is the function equals to? The function is equals to nothing when x is outside of this domain. So the function is equals to 0 otherwise. The function is equals to 0 otherwise. Okay, let's graph this function. Let's move that to the left like that. And then I will set up a vertical axis or y-axis and then an x-axis. So that is the x-axis, that is a y-axis. And then what are we trying to graph? The function f of x is just a fancy way to write a function. F of x means y equals to. So up to this point, I am sure that you studied the equation, the basic linear equation, and then the graph of equation. So let's say y equals to x. You should know what the graph looks like. If I give you y equals to x plus 1, this is the graph of a linear equation. You should know what the graph looks like. Let's say y equals to 1/2 x minus 3. You should know what the graph looks like. This is graph a linear equation. So what I am asking for is f of x equals to a fraction. But look, in this fraction, there is no independent variable. I have 1 divided by a real number minus another real number. So that is just like sketch the graph of y equals to 1/2, y equals to 2, y equals to -5. You should know what the graph looks like. This is the graph of a horizontal line. Y is always equals to this value. Y is always equals to this value. So let's say y is equals to 2, and then there is a horizontal line. at y equals to 2. The line is not going uphill, not going downhill. The graph of a horizontal line. This is the prerequisite of studying uniform distribution. So if you do not know the graph of this, you should do a quick review. It is not that hard. All right. So this one I have from A to B. Okay, let's put my lower limit A and then my upper limit B, like that. And then the f of x equals to that fraction. That is the same thing as saying y equals to 1 over, let's say, 5 minus 2. You should know what the graph looks like. And then that will be a horizontal line. And then I want this horizontal line ellipse between A and B. So at A, we have a point. And then at B, we have a point. And then this is a horizontal line. And then how high is this? Oh, I am supposed to do a writing, not erasing. This is the 1 over B minus A. And then this line, this is a horizontal line, can be represented by f of x equals to 1 divided by b minus a. So the body of the function is actually the height from the origin, which is a 0, 0, to the y value. And then this is not part of the graph. People usually draw a dashed line to connect the maximum and the minimum, but the dashed line is not part of the graph. The reason of doing this is you want to make this look like a rectangle. Okay. Speaking of rectangle, we will have to come back to this word later. So that is the graph of the function. So what we did so far is we sketched the graph of this. What is zero otherwise? Zero otherwise is when you are out of the domain. Let's say you want something right here, and then you want something right here. Do we have anything right there? No, because my horizontal line lives from A to B. That's it. If you are outside of B, there is nothing. Outside of A, there is nothing. That's what the zero otherwise mean. Okay, just like a binomial distribution, x is a random variable. So this random variable has an expected value, variance, and standard deviation. Let me erase this and then let me write it out for you. And then for expected value, for uniform distribution only, all right? So if you are doing another distribution, then and the formula will be the same. The rule will be different. This expected value is for uniform distribution only. That easy. You add the A and B and then divide it by 2. And then the variance of x, that is 1 over 12. This is always 1 over 12. Okay, this fraction always 1 over 12. And then b minus a and then square. Okay, so let me just do a arrow like this. So this is always 1 over 12, no matter what uniform distribution problem you are doing. And then the standard deviation is the square root of variance. All right, there we go. And then this is the expected value, variance, and standard deviation for uniform distribution only. And then what characteristics can we say for this graph? And do you remember the binomial distribution or just a general discrete random variable? You have a table, right? X takes on this value. Each x value has its probability, and then the sum of all the probabilities is equals to 1. But in this case, x is a continuous random variable. I cannot use a table and then say, okay, when x is equals to that is the probability. When x is equals to this, that is the probability. I cannot do so. What I can do is I can only draw a graph. So instead of giving you a table to describe the probability distribution, that is the table. That is equivalent to the table. So for a table, the sum of all the probabilities is equals to 1. For this graph, the sum of all probabilities which is the same thing as the total area. Okay, let me move this up. The total area, that is equals to 1. Can we verify that? What is the area of a rectangle? The area of a rectangle is length times width, or base times height. How long is the base? Let's say this is a 10, this is a 2, the base is big number minus small number. Not 2 minus 10, right? 2 minus 10 will be negative. Big minus small. And then the base is, you use the big number minus the small number. then that will be B minus A. Let's follow the color. B minus A, that is the base, and then the height is the function, 1 over B minus A. What is that equal to? That is equals to 1. And then let me say this again, and then this horizontal line between A and B represents f of x equals to 1 over the bigger value minus the smaller value. And then you need to make sure that x lives between A and B. This is a horizontal line. The line lives between A and B. We have one horizontal line. The horizontal line lives between A and B. And then before I end this video, I want to give you one more word, and then this f of x equals to 1 over B minus A. I know I wrote this so many times instead of saying a function, because a function, you use this word in algebra, pre-calculus, trigonometry, and calculus, right? But in statistics, we will be using a more fancy name. This is called a probability. Density function. And then we are taking the P, the D, and the F. We will, in short, we will just say PDF. So f of x equals to 1 over B minus A is a PDF for the continuous random variable x that is between A and B. Probability density function. Oh, depending on the books that you use, sometimes they use probability mass function. Same thing. It depends on your book. So probability mass function, that will be a PMF. In my career, I always use PDF. I took one graduate course. That book, they use a PMF, probability mass function, probability density function, PMF, same thing. You can just say function. In a statistic, if you say function, people know what you are talking about. But PDF is more like a professional and more sophisticated word. Right, so that is the introduction to uniform distribution, and then in the upcoming video, we will do some examples for that. Okay, see you there.